In this video, we're going to examine slope fields, which is one of the ways that we represent differential equations, that we can kind of work with and look at differential equations. But before we get into slope fields exactly, we need to talk about fields themselves. So a field is a math concept where each point in space is assigned a value or a number. So if you look at this here, this is a temperature forecast from a couple of years ago of Turkey. So, here in Istanbul, on that day, it was forecast to be 11 degrees. In, what is this? Like the Bursa area, you got 13. Up here on the Black Sea, it's 12. And you can kind of see all over the place. Out here in Syria, it was 19 forecast. So every single point in space gets a value, and in this case it was temperature. So this would be an example of a temperature field. Now for this to be a fully proper, 100% exact field, we'd need literally every point. So all these points in the Black Sea would need numbers. And then if we zoomed in infinitely close, we'd just see we'd see numbers at every point. But because we don't need all that detail, we're just looking for the general trends, we can look at this and kind of see, okay, we get the picture, between these 2 points, it was probably like 13, because we can kind of look for those patterns. And we don't necessarily really care exactly what it is. But a real proper field would have that infinite level of detail. So we can use this to represent our differential equations. So a slope field, also sometimes called a direction field, represents the solutions of a differential equation by depicting the slope at every point in space. So they show literally every single slope in this field. And that means it will kind of give us an idea of what the possible solutions are. So what we do is we represent these arrows with arrows that are parallel to the slope at that point, or tangential to that slope at that point, if you wish. So let's look at an example, because that'll help kind of make sense of things. So here's an example of the equation, or of the slope field for the differential equation y prime equals 3x plus 2y minus 4. So we can plug in x and y values, and that will give us slopes, right? Because this right here tells us the slope. So for example, if I plug in 1, 2, that will give me 3 plus 4 minus 4, which equals 3. So at the point 1, 2, the slope should be about 3. So at 1, 1, 2, I must have done something wrong here. This may not actually be the slope field for this expression. Or this is, I think the axes of these are different. I think these might be by halves or something. But anyway, you get the idea that this should calculate the slope at any given point. And you can plug those in, you can see all of those values. So I'm not sure why that 1, 2 is not working. Let's try a different point and see if I'm just being silly and overlooking something. So at 0, 0, the slope should be negative 4. And we see indeed at 0, 0, the slope is very steep and negative. Likewise, at 2, 1, the slope is going to be 0. And so at point 2, 1, we see a slope of 0. So the idea here is you can go through and you can draw a little arrow for every single point in space that's kind of parallel to the what the slope should be at that point. So again, we calculate the slope at every point and draw a small arrow that's parallel to that slope. Now, when you actually go to create slope fields, if you're going to do it for any sort of real practical application, you would just use a computer these days. On the AP test, they'll usually give the slope field questions on the multiple choice because it's not realistic, you know, be drawing all these arrows. It's kind of a waste of time. But if they do ask it on the free response, I've typically seen it between 6 and 8 points. They'll say like for these 6 points or for these 8 points, sketch the slope field. And typically there'll be a mix of 1 and -1, 0, and like 2 or half or -1/2. Things that are pretty easy for them to look at and see if you have the right idea of those slopes. So how do we use slope fields? Well, the solution is any function or any equation that matches, is any curve, that matches or obeys the slope field. So what you do is you try to follow the arrows to sketch out what that function might look like. So for example here, we've got the function t prime of t equals -0.4 times t minus 72. And we're way high up here, like these are in the 70s right now. And this solution right here is about 0,70 is this point. And this point right here is about 0,74, just so you know where we are on the graph. And you'll notice that these lines kind of always follow sort of the same direction as the arrows. And that makes them a solution. So if we might say like estimate the solution from here, well, I'm just gonna, you know, sketch and kind of follow these arrows and then follow them backwards, and that's a solution. Let's jump back to the previous slope field we had, because this is a lot more interesting to find some solutions on. So one solution might be this line here that's pretty close to a vertical line. Imagine it was vertical because it lines up with these arrows. Then we also have solutions like this and like this. And you have this one that's gonna kind of come and maybe go like that. And this one that's kind of come like this and eventually curve up like that. So you get the idea that we can kind of follow these arrows and draw our curves, and that creates the solutions to those slope fields. So that's the idea behind slope fields. The Khan Academy is a great practice with this because they give you lots of these things already sketched out. If you have any questions, let me know.